New companies and tech this week have dominated the news as well as space. Dominance within space at both the LEO and GEO levels remain a sergeant major theme for the new year as we see increases in SDA, RPO, and even defensive capabilities. With us to marshal the topic is Trevor Smith, CEO of Atomic-6.
Also heating up are some thermal and infrared imaging projects, as friend of the show HydroSat announces the close of their Series B round. Aurora Tech launches their first payloads, and Orbital Sentry comes out of stealth.
NASA's SLS, or Slow Launch System, has almost started its engines for Artemis 2, meaning that they're crawling out of the gates and are neck and neck with PSLV and Ceres for successful launches to date in 2026.
Welcome to this week's episode of Space Times Podcast. As always, I'm Harrison Lambert.
Here with Paul Mayer.
Excited to share this week's space industry updates with you. We hope you enjoy this week's episode. Drop us a comment, check out our socials, and please follow us on Spotify, Apple Podcasts, YouTube, or wherever you're receiving this signal. One of the main topics dominating the news cycle this week has been space dominance. Typically, we've talked about this in the form of space situational awareness, space domain awareness, but we're actually seeing some movement across all the different branches, whether it's awareness or actual activity in space or just, international conflict over allocation and coordination. Probably the biggest number we saw this week that was kind of mind-boggling was that China filed for 200,000 satellites in GEO with the ITU, that's the International Telecommunications Union. They regulate who gets access to where. So this is split amongst two constellations, CTC-1 and CTC-2, each for exactly 96,714 satellites. So roughly around 190,000 satellites. These are private companies within China, but China has confirmed that this is a valid request. But that's a number as big as this. It's really hard to take seriously that it's actually going to get to orbit, because this is about 8 times as much as all space vehicles in orbit right now that are both active and inactive. It's like a 20 times multiplier over what's currently active. And so this is a huge increase. The last time we saw something this big was when Rwanda filed for 300,000 satellites back in 2021. And that was basically a marketing stunt. So I expect this is very similar for China, but there seems to be some role here to play in kind of blocking out that orbital domain from other countries trying to get the same access like the US.
Yeah, it's sort of regardless of how many satellites actually wind up going up, because you're absolutely right. 200,000 is a completely impractical number. But regardless of how many satellites wind up actually going up, it's worth noting that this call out and this entire filing is dedicated for GEO, which generally speaking is the much less populated, much less competitive, much less already sort of dominated of the orbit domains. So this very well could sort of signal that China is sort of, okay, LEO and VLEO are already pretty saturated. They're already pretty populated. There's already a lot of competition. They're more of a red ocean than a blue ocean, so to speak. We're going to go ahead and take over and win the slices of altitude and the orbit domains where the space is a little bit less mature and a little bit less defined.
Yeah, and it follows the patterns we saw last year with the Xi'an demonstrations from China to do RPO and GEO, and they're very focused on GEO. I think there's just less contestability as compared to LEO, which, as you said, is very dominated by the US right now, primarily Starlink. So blue ocean domain, I think it gives them also a bit of cover for their satellites in terms of tracking and interception. So I think some of the news that we've seen from SDA companies this week is interesting. Vioma has successfully launched Flamingo 1. It's their first space domain awareness satellite to a 500-kilometer sun-synchronous orbit. We're seeing an increase in satellites doing SDA as opposed to the traditional ground-based SDA sensors. Vioma has a combination of both, but I think what the satellites help benefit is better accuracy and tracking, and it gets them closer, it gets them out of the atmosphere, gets them a clearer picture. I think it will benefit hugely as we get more populated across all domains, especially in GEO. In that same vein, Slingshot Aerospace was awarded a $27 million contract to support the U.S. Space Force in advancing next-generation training for space warfare. So this is a signal that the U.S. Space Force is taking very seriously active actions in space, both defensive, offensive, this RPO technology we keep talking about. The work is focused on integrating Talos AI into the U.S. Space Force training environment, scaling scenario complexity, increasing realism, and enabling operators to prepare for rapidly evolving orbital threats. This makes sense given the news that we've heard about Slingshot recently. They are also an SDA company. They've gotten contracts out of the UK to track some satellites. They recently did a tracking of a stealth satellite from Russia called the Mosaic 5. So they are very capable. And I think that the capabilities that they've both built and demonstrated are going to be a huge boon for the Space Force as they build up some enhanced warfighting capabilities for space.
Yeah, there is a definite pattern this week with multiple different entities and multiple different companies seeing a lot of money flow into the, I'll say, space intelligence ecosystem. Slingshot Aerospace playing on the early side of that space intelligence, where it's more about projection, simulation, and training effectively. But there's some big announcements as well happening, some big consolidation and a lot of growth and money flowing into the space intelligence, both with intelligence derived from existing products and intelligence meant to preempt some of the actual assets on orbit and their capabilities.
Yeah, and this is on the flip side of the awareness aspect is the rendezvous proximity operations aspect. So traditionally, this is mentioned as like a docking, berthing, in-space manufacturing, refueling kind of technology, but increasingly we're seeing this used as a offensive or defensive capability. Some of the news that we saw out of this RPO technology this past week is from the Proba 3 rendezvous experiment, which was successfully completed by Indra together with partners in the RVX consortium. This is the ESA and the Education Center for the ESA. So this is, great news for Europe. They've had some demonstrations the past year with France and UK, and they've been talking more about doing RPO. And Indra is one of the stakeholders in the SpainSat NG2 satellite that got hit by orbital debris last week. And just this week, they wrote off as a complete loss. So I'm really glad to see they've got some success somewhere on some of their other missions. Astroscale UK wins an ESA contract for IRUS in-orbit refurbishment and upgrading. Astroscale won this contract for an 8-month Phase A study aimed at developing the technical groundwork and commercial case for such services. And Allspace has raised $2 million in pre-seed funding to develop technology to extend the life of high-value satellites, inspect space assets at close range, and safely retire non-functional satellites. So as I said at the beginning, there's a lot of applications for RPO, but we're seeing them spread across, world life extending technology, as well as, inspecting space adversaries and doing sort of space warfare activities.
Astroscale UK's announcement comes on the back last week of Astroscale Japan's announcement for the, I believe, $6 million, 1 billion yen, but $6 million contract to develop and implement the satellite grabbing or grappling technology that they have. So the fact that they've gone back to back in completely different nationalities and completely different states in winning what amount to the same capability is indicative that they have some pretty well mature capabilities and some pretty well developed technology for doing so.
With all this activity in space and the increase in space presence, there's going to be this conflict. There's going to be this challenge of space debris and collision avoidance. That's what a lot of these SDA technologies are trying to help develop against, is making sure that satellites don't collide into each other and generate debris that's going to generate more debris. And so some of these companies are starting to look at removing the debris in order to try to mitigate that problem as we add more to space. iSpace was awarded a contract by the Japan Aerospace Exploration Agency, or JAXA, for a lunar debris and disposal management study, which is great to see. We'd rather stop this problem from propagating out to lunar orbit than trying to clean it up there after the fact. But closer to home, we have ClearSpace and ESA targeting 2027 for Prelude, which is in-orbit servicing and active debris removal. So some of this RPO mixed with actual activity to remove some of this debris. It is positioned as a 2027 demonstration mission to develop core in-orbit servicing technologies and active debris removal.
Yeah, I think the Prelude project is really interesting, specifically because we've seen such a rapid growth in the need for space debris mitigation. You're absolutely right that historically it's been effectively a non-factor, and that's great right up until it's not anymore, right up until space debris and the chance of sort of a third-party liability problem coming up, or the chance of a satellite failure as the result of what would otherwise be a preventable problem. Once that becomes non-zero, then we have a really big challenge to overcome here. And ultimately, what the partnership between ClearSpace and the ESA are targeting here represents a fundamental attempt to assuage that concern and to try and preempt any sort of Kessler syndrome cascading failures.
So these kind of activities are, they're higher agility satellites that can move around in orbits, go to do different activities. That makes them inherently more risky to be hit by debris, either because, they're doing these operations that make them slow and bigger targets, or they're actively going into areas where there's higher debris density, which gives them a higher likelihood of being hit. For the longest time, we kind of waved away this problem statistically as like, it's not going to happen. But as this becomes more and more of an activity, I think the likelihood is going to go up. One of the companies that is kind of playing with this situation is Portal Space Systems. They have a high agility spacecraft that they are flying later in this year called Starburst 1, intended to go do some activities in higher debris density areas. And one of the most exciting things that we've seen this week to be an advance in tech for that kind of application is Space Armor, which is a debris shield developed by Atomic-6. This is an advancement upon the Whipple shield design that's been around since the 40s that traditionally has really only been used on the ISS because it's bulky and massive and not very conducive to agile satellites. And, it builds up the mass, makes the cost higher. So it's great to see that Portal Space Systems has selected Atomic-6 space armor to reinforce some of their critical space systems so that as they go out into this mission, the chance of a debris hit knocking out their satellite is reduced. So to kind of dive more into this general, space defensiveness capability that we're seeing, and particularly this announcement from Atomic-6, we've had the opportunity to interview CEO of Atomic-6, Trevor Smith. We are going to cut to that interview now and come back for the rest of our main topics after. And so going over to the space armor, I know you have a very cool announcement about it with Portal Space Systems. That will be your first flight for space armor, I believe. We saw some funding for this in development, but I believe this will be your first time testing it in space. So I was hoping you could kind of give us the rundown on this particular product.
Yeah, you're the first ones that I'm talking to about this because the embargo lifts tomorrow, so it feels a little weird. But yeah, happy to talk about it. So Portal Space, they have a really unique capability. I'm good friends with the CEO, Jeff Thornburg. For background, Jeff was one of the chief architects and really responsible for that Raptor engine that powers the Falcon 9 and Starship. So the guy knows a little bit about space. But Jeff and I became friends over the past few years through a accelerator called Creative Destruction Lab. They have a space accelerator. Actually, Commander Chris Hadfield started it. I know we were talking about
cool.
So I met Hadfield there and I met Jeff there. But yeah, so Jeff, their system, I can't speak to where they will be flying and all of that, but they anticipate a likelihood of some sort of impact, debris impact. And so they are placing space armor over critical systems, right? So fuel tanks, avionics, things that they can't have go down. Recently, I don't know if you saw in the news, but the Chinese astronauts got stranded because so their return vehicle, I looked it up. The news said it was something less than 1 millimeter of an impact, a debris strike.
Yeah.
So just for reference point, over 90% of debris in LEO is 3 millimeters or less. And that is also untrackable. So you don't know to move. You don't know it's coming. That's why space armor is picking up. And also, I think a week ago, the Spanish satellite, I think it was a debris strike, and it was like a $400 million insurance claim because of a debris strike.
Yeah.
So unfortunately for the space industry, I think this is just going to become more and more of a thing because we're launching more things into space. Kessler syndrome, if you're familiar with that. I spoke with Don Kessler a few months ago, really nice guy. But I think you're going to start seeing satellite operators, builders, bus builders start implementing protection from the early days into their system designs, because this is just going to become more and more of a thing. The benefit of this, though, as you mentioned, Harrison, as opposed to a Whipple shield, because I know you talked about this on a previous episode, the Whipple shield, when you hit it, there's secondary debris impact, post-impact ejecta. So you see a video on our website, there's a metallic shield and then there's space armor. The metallic shield gets hit and more debris comes out, is delaminated from that monolithic block of aluminum than the original mass of the projectile coming in. The unique thing about space armor is that there's really no harmful secondary debris creation. So that video is at 1 million frames a second. I've watched it 100 times. There's the idea that we could not just protect our spacecraft, but also help minimize additional debris creation, I think is a great thing. And a total byproduct of us building this. A total accident.
Yeah, cleaning up space.
Yeah.
One of the things that I want to follow up on with regards to space armor is the growing market, I'll say, of secondary or aftermarket space assets. We've seen a multitude of different companies that are focused on refurbishing and deorbiting existing assets on space. They go up, they come back down, they get refurbished, and then they get back up again. So there's obviously some unique and special needs. There's a lot of efforts going towards specific types of heat shielding so that assets can be brought back down through orbit. There's multiple different vehicles that are looking at potentially grabbing assets and then returning them safely themselves. And those will need specific types of touching and inflammation. And I'm curious, how do you see that sort of, I'll say, that used car market for satellites developing? And where do you see space armor sort of fitting into that, in so many words, of protecting the assets that are up there while they're up there?
So space armor is designed for demisability. It is not a heat tile, right? You don't want to use this for reentry. So it will demise upon reentry, which is what you want from your deorbiting satellites, because you want them to demise and not come crashing into Earth. So while reusable satellites, there's lots of people working on it, I think are great. The satellites that are up there, our goal is to keep them operational longer, reduce the risk of impact and mission loss, and hopefully last longer than their anticipated mission.
So you don't necessarily see a way, or you don't necessarily, it sounds like, view space armor as a method of helping to tackle that sort of used car market. Not certainly not as a method of reentry itself, but as a core component of, you need to rust proof your car, you need to rust proof your satellite before it goes back up. So like space armor fitting into that ecosystem.
Sure. Yeah. So that's exactly why we wanted customers to be able to implement this into the vehicle very easily. So we have 6-inch hexagon shaped tiles. And so Portal, as an example, ordered multiple tiles and they will put them next to each other and really cover the surface area that they want using that hexagon shape. Does that make sense? It makes it easy to like puzzle piece the areas that they want to protect. So if you've got a satellite going back up into service, a used car, and you're like, hey, I'm worried about this area, maybe it already got impacted or we added some critical component, you could very easily slap a space armor tile on the outside and protect that area on your used car, so to speak. What's also unique, we haven't talked about it yet, but to my knowledge, space armor is the very first radome ever built for space. So the uniqueness of the material set not just stops space debris, it allows for radio frequency transmission through it. And then we have a version that also can block it. So for certain customers, parts of the spacecraft, they want RF transmission through it. And other parts of the spacecraft, they actually want to block that transmission, whether it's for interference or numerous other reasons. But we can basically have an RF permeable and RF blocking version of space armor, which opens up lots of new ConOps, because no one has ever been able to protect their communication system from a debris strike until now.
Yeah, that's super valuable, especially when we talk about like AST Space Mobile and their giant like deployable phased arrays. I know you brought up phased arrays as an option there. So like as these comms payloads get bigger like that, they're going to be a bigger target.
Yes, that is for sure.
So I know you mentioned that the space armor was rated to 7 kilometers per second, and I believe space armor max is up to 1.2 millimeter size debris.
So you just mix,
12
you mix some metrics there. Space armor light is rated for 3 millimeters and less. Space armor max is 12.5 millimeters. What has gone through flight qualification and what Portal is flying is the light version. We have not finished qualification on max, just because we had customers out of the gate asking for that 3 millimeter protection because they're unmanned systems and just don't need that higher level of protection.
And when you fly on Portal, is there something you're testing for? Like, is there a way for you to tell if the armor gets hit? Or is
fortunately or unfortunately, I hope Portal gets hit, but just gets hit in the right spot. So they are going to be flying with the tiles on there, and they'll have cameras. I think they'll have at least 1, maybe 2 cameras pointed at space armor. So you won't see the moment of impact because the projectile will be moving too fast, but you will see the before and after, and you can compare the telemetry on the spacecraft to see if anything bad happened, right? So in an ideal world, the camera will show a before with no impact, and then there's, a bullet hole, if you will, in that front part of the shield, and then you confirm with telemetry that nothing bad happened to the spacecraft. That is the best case scenario for us over that 5-year period. I hope it happens on day 1.
So is that how you expect to measure it in production when it's deployed to a larger set of satellites? Or
well, so I mean, I don't know that everyone will want to monitor them all. I think long term, we have been talking about embedding sensors into the armor itself that you can tie back into the spacecraft if you're really worried about it, which, Paul, plays into the insurance side of the things, because you could relay live data on debris strikes on your constellation if you have embedded sensors into the space armor tiles. So you know where you got hit, how bad you got hit, how often you're getting hit. And that data could inform the underwriting for these space insurance premium folks.
Yeah, and I think we saw this recently with a company called Odin Space. They're building a radar sensor for satellites as sort of a black box to track collisions with the spacecraft in order for what you said to underwrite insurance claims. So I'm really interested in kind of the interplay here of defending against and actually like proving you've defended against something.
There are a couple of people we've talked to at Space Force, and we're like, would you be willing to fly directly into a debris field? Actually, that sounds kind of fun.
Yeah, that's some Han Solo stuff there.
Yeah, but most customers will not want to do that. But they do want that protection because of the things that they can't track or see and know to move. So that's why space armor is there.
And so going back to the ratings that you gave for the light and the max, they both seem pretty tailored towards the low Earth orbit environment, where there is a lot of small pieces of debris that have built up over the years, paint flecks and whatnot. And 7 kilometers per second is coincidentally kind of the orbital speed at that altitude.
Yeah, it's 7.5, depending on where you are. And if you, for some reason, get hit in retrograde, you're looking at 14.
Yeah.
Which there's no hypervelocity gas gun on Earth that can hit that speed. We're maxing out the gas guns at Texas A&M at like 7.2, 7.5. Don't quote me because it kind of changes with the size of the diameter of the mass. But we're trying to just test for the most broad use case in LEO because that's where all the debris is. And as you go out to MEO and GEO, those velocities will go a little slower.
Okay. So do you think it's still something that can be used in GEO? Because as you mentioned with Hispasat last week, it got hit at like 50,000 kilometers out. And China just submitted for approval a proposal for 200,000 GEO satellites being put into orbit, as well as all these interactive RPO demos going on in GEO. So I think there's a lot more activity that's going on out there. Is that a market that you see as complementary, something you can expand into?
Well, so as you move out in orbit, the projectile orbital velocity gets slower, right? So the closer you get to Earth, the faster it is. You got the GEO, it gets a little slower. So it's an absolute market. We were optimizing for the most customers and the highest speed, which would be the highest bottleneck for protection. But as you go out, absolutely. And again, I don't know where Portal's going to be flying, so maybe they're taking it. I don't know. We'll find out if they, let us talk about where they fly.
And is the space armor something that you'd be able to like layer up if you kind of built a Whipple shield out of it? Does it increase its capability or? is it diminishing returns?
I mean, you're adding additional protection. Sure. We've had some customers ask, well, if we get hit and we had a robotic arm, could we apply another tile in space with this robotic arm and just put it over the one that got hit? Absolutely. That's why it's made in a tile form. So like you could think Pez dispenser, you've got a robotic arm and place it. Like today, that's what they do in the ISS, but instead of a robotic arm, it's astronauts. Not a safe thing to do, right?
Yeah. And it's interesting thought as we get more towards reusable and orbital refueling depots, and a lot of these kind of portal-like companies can do more than one mission.
I would love to see space armor inside an astronaut suit doing spacewalks.
So you had a really interesting kind of entry into the space industry. I know you founded a company before, but I also noticed that you've had like a Beer Street Journal and you have your own podcast, driving around hypercars. So, what, like, is space the coolest thing to you, or is it driving supercars, or, like, what do you think of the industry that you've been working for years in now?
Space is the coolest thing. Beer was fun, but actually, I think you're the first person to bring that job up. No, the Full Burn podcast that I do is a way for me to interact with really unique, awesome people in the space industry and have a good time doing it. And so I just enjoy doing that podcast. There's no sponsors. I don't really look at the views. I just do it to connect with those founders that we're interviewing on the podcast. And we happen to be doing it in Ferraris and Lamborghinis and speeding on occasion.
Awesome.
Awesome. Yeah, Trevor, thank you so much for joining us. It's been a fascinating conversation, learning about your background, learning about everything that you're working on at Atomic-6, and sort of where you think the industry is going and what you're building and designing. How can we and our listeners help you? What are you looking for? What do you need these days?
I need smart engineers. I need smart people. I need people who want to be on the mission with us. Right. We need to grow the team. So there's that. We want customers who need lots of power and protection with light wing and space armor. So would love to talk to bus builders or end users for that. And just a general excitement about the space industry, I would say, right? Just be excited about the industry, because I think we are like Space Race 1.0 and we went to the moon. It's the Wild West right now. Like, Musk might make his own laws on Mars if he's the first one there, and like, weird, like, it's basically international waters. I think it's such a unique time to be in the space industry because the rules haven't really been set. So I can't wait to see what gets set and who sets it.
Yeah, thanks so much for joining us, Trevor. I look forward to following your success with Atomic-6 and keeping track on your Full Burn podcast.
Thank you. Thank you, guys.
Moving on down the line, we've got some major announcements out of the low Earth orbit space here. To start us off, Aurora Tech and Kepler launched their first project satellite together. So Kepler launched a series of satellites with different Aurora Tech Sapphire Gen 4 sensor payloads. These were launched January 11th aboard a Falcon 9. And effectively, the product capability that Aurora Tech is promoting and selling is the first real-time live stream, the first thermal live stream or real-time imaging data of Earth. Super, super impressive product capability, just because that is something that we haven't been able to see. We haven't been able to see live streaming data from an orbital asset because the latency and the lag time in order to get that is really traditionally prohibitively high. So I am super excited to see how Kepler and Aurora Tech have solved both the bandwidth problem, have solved the downlink problem, and have solved the ground station problem, all different stages of that traditional bottleneck. But Kepler Communications has launched the first 10 satellites of its optical communications constellation, and 4 of them have hosted Aurora Tech payloads. At the same time, Orbital Sentry, a company solving a very similar problem to Aurora Tech, has come out of stealth. Orbital Sentry is solving a complementary problem set, but doing so from a geostationary and geosynchronous orbit. So they're building bigger birds that are able to hover in place over the areas that they need to observe. And by doing so, they don't need to actually build out the constellation that Kepler needs to build out in order to provide that level of constant data input and data downlink. So really interesting to see both of these companies making announcements and making progress simultaneously at the same time. Should be a lot of fun to see how they develop.
I'm really fascinated by the Aurora Tech and Kepler partnership, because it's one of the first Firesats to go up. There's been one in development for a while at Muon, but Muon vertically integrated their whole stack. So besides the Placer terminal, so Muon took a very different approach. And between these two companies, it's really cool to see that all three took very different approaches. I like Aurora Tech's approach because it's leveraging Kepler, and it's almost as like a secondary payload to Kepler. So those 10 satellites they launched on the Twilight mission last week were for the first tranche of their 50 satellite constellation to build out their proliferated communications network. So that's, just launching those alone is a benefit to Kepler, but adding this extra capability to do images for fire detection is awesome. And the kind of design that Aurora Tech went with is more mass intensive than what Muon's approach is. But I think it makes it a lot simpler to integrate it onto a satellite that wasn't really like tailor made for this particular application. So Aurora Tech, really cool wide field thermal infrared sensors on top of Kepler's laser integrated terminal system means that Kepler is using a different approach than Starlink. They're using laser terminals to connect their satellites. They're using laser optical communication to communicate to the ground, which they demonstrated a few months ago with space to air communication. So, if everything works great, then they've got a really higher speed optical communication link between all their satellites carrying these sensors and to the ground. And so that, they're able to get that working, then live streaming fire data is totally within the realm of possibility. It's a lot of data. A traditional satellite probably wouldn't be able to carry that much, but if they can get that orbital link, that optical link working to the Earth, it's a huge step up over what Muon's doing, which is having a Placer terminal on board their Muon satellite, and just one. So it's not like a constant connection. It's just whenever they can connect to Starlink, one of the orchestration satellites, they can get a high data rate through, but then they get bottlenecked at the space to ground level. And they have the complexity of an optical terminal that's spinning around, as well as their imager is optomechanically steered thermal infrared imagers. So they have two mechanisms moving around, which makes a lot more complicated design. Orbital Sentry has a great design, but then they have to put in a bunch of geosatellites to cover the Earth. So it's a lot more focused if they're only getting contracts for certain regions. But I don't know, just overall, I find it really fascinating, the breakdown between designs between these three companies.
Yeah, it's the fact that they have such different technological solutions to the same problem is fascinating. I personally find the different business models necessary to facilitate those different technological solutions really interesting. So the fact that Kepler owns the buses and that they own the communication layer for the entirety of the satellites, and that they already have the partnerships in place. So effectively, they own the communication and the downlink layer for all of this, and that Aurora Tech is effectively just a hosted payload. The question then sort of becomes, in my mind, whether or not that is a sustainable mode, because effectively what Kepler is doing is they're demonstrating, hey, look, we can do what we say we're doing. We can do this with somebody else's payload that's doing this much data, this much stuff. They could very well go out and then sell that payload space to anybody else. They could sell that payload space to effectively, rather than an Earth observing asset, they could sell that and instead make that a receiving asset, so that the Orbital Sentry team could theoretically put laser communication terminals on theirs and go directly to Kepler, and then Kepler could immediately take that down. So there's sort of a definite risk here in the joint venture between Aurora Tech and Kepler, that one of them could effectively outgrow the relationship. And so this works really well now. And if they decide to go ahead and move forward together and develop a bigger satellite constellation, they'll be super successful doing so. But Aurora Tech being a payload and being dependent on Kepler's infrastructure puts them at a definite risky spot until there are substantial other, I'll say, avenues for Aurora Tech to achieve that same end goal. So I think if Kepler is building out this laser terminal, this optical laser communication and ground station layer, then a future in which they partner exclusively with Aurora Tech, I think is less likely than a future in which Aurora Tech becomes one of several partners who all wind up communicating with Kepler's satellites that don't actually host any EO payloads themselves, but wind up hosting a whole bunch of receiving and sending hardware necessary for them to connect with whomever is out there trying to send data back.
Yeah, it's a good point, because like Aurora Tech will only have like 2 to 6 updates a day, whereas Muon's saying they'll have every 5 minutes, and Orbital Sentry would be constant. So there's a downstream effect there as to the value of what they're gathering.
Right.
I also find it fun because like this is the mission profile they have in the space missions and design textbook, and so like it's like 3 different companies read that textbook 3 different ways, different solutions.
Oh, that's fun. That's fun. All right.
It's been around since the 90s, man.
Additionally, Planet wins a low 9-figure deal to deliver a suite of satellites, space-based data, and AI intelligence solutions to Sweden. This contract is not explicitly valued, but it's reported to be somewhere in the hundred to hundreds of millions of dollars. But this represents the 3rd satellite service deal for Planet in the last 12 months and over $500 million in total bookings. And it represents a pretty big continuation of demand in the Earth observation space. There were some concerns about that starting to taper off in 2024, 2025. Whether or not the demand for continuous live ongoing Earth observation would still be there if you already had yesterday's pictures. This in conjunction with the Portuguese Center of Engineering and Product Development buying about $20 million worth of satellites from Satellogic, specifically 2 NewSat Mark V imaging sats, roughly 50 centimeters in scope. It is fairly indicative that this asset class and this product class is still in demand and isn't actually on the downside.
Yeah, definitely like sovereign capability indicator.
Yeah, we're seeing that throughout Europe, and it's again everybody wanting to vertically integrate their own capabilities. Additionally, Airbus has been awarded a Eutelsat contract to build a further 340 LEO OneWeb sats. So this brings them up from, I believe they have a contract procured in December 2024 of 100 LEO satellites, brings the total number of satellites ordered up to 440. And if memory serves, we were talking about this off air, but if memory serves, Harrison, the stated goal is to get about 500 LEO satellites on orbit, somewhere in that ballpark, 500 operational satellites on orbit. So a chunk of these...
I double checked. They actually have 600 on orbit right now. So this would likely be a replenishment, I think.
Okay, yeah. So definitely some replenishment happening there in order to keep them at their desired level of saturation. But big contract, big award for Airbus and Eutelsat. Additionally, Aleria has been selected to take part in the new Airbus Up Next Space RAN, Space Radio Access Network demonstrator. And so the mission of this is to standardize global 5G non-terrestrial network connectivity. So this doesn't necessarily compete directly with a direct-to-device network and the direct-to-device product suite, but it's definitely a step in that direction, coming from purely terrestrial-based networks where you have to go to a ground station, you have to go to a radio tower, and then you get rerouted and your signal gets changed therefrom. This is definitely a step towards having that infrastructure in orbit. So you're not necessarily going directly from asset to device, but there's a definite push to keeping more of the infrastructure and more of the communication layer in orbit here.
Yeah, it's interesting news to see in the same week as OneWeb buying more satellites, assuming they're not like ready to procure. It's going to take them a couple of years to build that many satellites. The integration of Illyria into their tech stack is potentially an upgrade to their spacecraft. OneWeb has talked about incorporating optical terminals into their V2. So that would be this batch of satellites. Currently, the ones on orbit do not have that. So it's very possible that Illyria will be the supplier for that particular subsystem. I think this demonstration will be done in parallel to kind of build out this 5G network, which is key for direct-to-device technology. And if it goes well, I could totally see them being bought for 440 satellites, which is generally 3 to 4 optical terminals per satellite. So that's close to 2,000 terminals being bought from Illyria, which is an up and coming space optical terminal company in general. But this would be a big order for them. They were a space they're an optical terminal company that was spun out of Google X. And they have some key, differentiators in their technology. But I really hope this demonstration goes well for them, that OneWeb is able to incorporate this capability, because increasingly a lot of these proliferated networks are adding the ability to have optical terminals between their satellites.
Yeah, the big bottleneck that we had from say 5 years ago in the space industry was primarily around inter-satellite communication, and it's great to see how much optical terminals have stepped in to mature and solve that. And the non-terrestrial network and direct-to-device capabilities that we're seeing develop and mature today would simply not be capable without this technology already matured and developed at the baseline. In other news, Liechtenstein has revoked Rivada Network's Ka-band licenses and given them to Open Cosmos. So Liechtenstein has swapped from one UK-based satellite constellation provider to another, and it bodes well for Open Cosmos and bodes pretty poorly for Rivada Network. Would not be surprised to see some additional announcements coming out in the next few months here between either of those companies. Additionally, Orbion Space Technology delivered 33 Aurora propulsion systems to York Space Systems for a defense constellation. The flight hardware is designated for use on spacecraft with an upcoming military constellation. And the implications of this are pretty interesting. So effectively, York Space is talking about and exploring an IPO. And York Space's biggest competitor is Rocket Lab. So over the past year, Rocket Lab has started to buy up and acquire some of their own suppliers, which, because Rocket Lab as a satellite manufacturer and York Space as a satellite manufacturer are more or less direct competitors, Rocket Lab's suppliers are York Space's suppliers. So Rocket Lab now owns multiple steps, multiple layers of York Space's tech stack, because they've gone out and acquired some of their own suppliers. So the thinking here is that, hey, there's some reason to believe that Orbion Space Technology, an electric propulsion provider, might get acquired by Rocket Lab, who doesn't yet own their own in-house propulsion solution. They may look to acquire somebody. They may go ahead and acquire Orbion Space. And so if York Space Systems winds up thinking, hey, okay, we've got this IPO, we've got a whole bunch of capital, we should try and consolidate, we should try and vertically integrate, and we should try and protect ourselves from our tech stack being bought out and owned by a competitor, we might see a bit of a bidding war between York Space and Rocket Lab over Orbion Space Technology, as they do seem to be well positioned and well primed for an acquisition. They've got their propulsion systems well matured. They've got them in a lot of different satellites, and they've got them well de-risked and established.
Yeah, I would totally expect an acquisition to happen for Orbion. As what you said, like, I think it's going to be a race between York and Rocket Lab. Like, Rocket Lab's currently tied up trying to acquire Mynaric, which is the optical terminal system that York Space used during Tranche 1 when they launched 16 satellites for that PWSA contract. The 33 propulsion systems is suspiciously close to twice as many as that, which is how many in total were launched for each tranche. So there's like 16 from York and 16 from Terran Orbital. So this to me indicates that they either won half of two more tranches, or they've won an entire tranche, or this is a follow-up to tranche one. There's a lot of speculation that Rocket Lab was going to eat York Space's lunch because they won not just one tranche 3, but are being deployed, some of their tech's being deployed across all of the satellite providers for tranche 3. So they bought GOST last year, and the Starlight system that they got from GOST is being deployed on every competitor spacecraft. So not only are they making money from launching their own spacecraft for PWSA, but they're also making money from every competing spacecraft. I would very much expect to see the same play here. I think them acquiring Mynaric is that play. And I think Orbion is in a very similar situation where if they're providing technology to their competitor, Rocket Lab might just buy that technology so they make money off of this as well. So if York Space is still in the race to compete with Rocket Lab over who gets most of these PWSA contracts, I think this is a significant component in that system. And I really expect to see Rocket Lab kind of racing to acquire them, whereas York Space will have to race to IPO to get the money to acquire them. So there might end up being a bidding war for Orbion here soon.
Yeah, there's a lot of similarities between how Rocket Lab has gone about building out their own, I'll say, like technology moat, and to what Redwire has been doing effectively with sort of testing out these technologies and then acquiring the technology, acquiring the capacity, acquiring the capability, and extracting rent on them throughout the ecosystem, not necessarily making them proprietary and making them unavailable to anybody else in the space, but meaning that, price goes up, we get our cut, our beaks get wet a little bit. So there's a lot of similarities there, and it has worked pretty darn well for Redwire to date. So I would not at all be surprised to see Rocket Lab like, hey, this is working for us. It's helping us to make stuff at a better cost, and we're also able to still make money off of any contracts that our competitors win. So I would not at all be surprised to see that be a priority, and to see York Space come to the same conclusion that we have if they're not already there, and try to beat Rocket Lab with a punch.
That's fair. I would compare it more to SpaceX though, and they bought up companies to vertically integrate, whereas Redwire doesn't vertically integrate. They are pretty much only a subsystem supplier. It just, to me, feels more like Rocket Lab is accelerating faster towards having an open ecosystem than SpaceX did. Like when they acquire optical terminal technology, it took them a while to actually allow another company to use the Placer like they did with Muon. Whereas Rocket Lab like buys these companies but doesn't close them off. So they are able to vertically integrate like SpaceX did, while at the same time using that technology to bring in new revenue streams, which I think is a really smart play from them.
Well, either way, it's been successful already, and it continues to be a successful play. So very true. Very true. Additionally, Aerospace Lab has been contracted to build 8 satellites for Zona Navigation and their upcoming constellation. So this partnership represents a Belgian manufacturer supporting early rollout as the U.S. commercial position, navigation, and timing startup builds their in-house production. Whether or not Zona is able to actually execute on these deals now that their bus and their satellite supplier and manufacturer is a European ally remains to be seen. Whether Zona Navigation is able to execute on this model with their proprietary PNT startup technology being paired up with an international satellite manufacturer and supplier for some of the government contracts that they're looking to pursue, that remains to be seen.
The launch industry has had a rapid pace to start off 2026, although quite a few stumblings over the starting block. To kick us off with a bang is the SLS. This is the large American rocket to take us back to the moon. It is now rolling out to the pad for the Artemis 2 launch next month. So that's a whole month of moving the rocket down the street. The last time they launched this was in November of 2022 to put the Orion capsule around the moon. This will be a progression of that mission to improve our ability to travel to the moon. We wish Artemis 2 great luck, and hopefully they can pick up the cadence, because the only thing slower than rolling it out to the pad is getting it to a second launch. 3 years since the last one, that's quite a long time to wait. Similarly, the long cadence in launches was the ISRO PSLV. So that's India's polar satellite launch vehicle. It is one of the workhorses of the Indian Space Agency, but it hasn't launched since May of 2025, where the C-61 mission failed to insert into orbit. The C-62 mission launched just last week and also failed to get onto orbit and lost 16 satellites with that rocket launch. This is a back-to-back failure on a key rocket for Indian Space Agency and drops their reliability rate to below 95%. So hopefully they're able to get back to the pad, but I'm sure they're going to be taking a long time looking at this data to try to improve the reliability of the launch vehicle, because two failures in a row and a launch vehicle that's losing satellites with such a low reliability is not great for one of the core rockets that they use. They still have, other satellites such as the GLSV, so that's their Geo Launch Sat GSLV, their Geospace Launch Vehicle, as well as their LVM-3 rocket, which carried Bluebird 6 up to orbit last month. In China, they're not having much better luck. The Galactic Energy Series 2 failed in its debut flight. They had the Series 1, which is successfully launched 2 days earlier, so they have a rocket that's working. But it's unfortunate to see the Series 2 fail. This is a newer kind of Falcon competitor from Galactic Energy, so it's not totally unexpected. We've seen Land Space fail. We've seen Long March fail. We've seen Space Pioneer fail at the same effort. But the fact that they're all launching and they're all making progress is a great sign. It's just sad to see after the Chinese Long March 3BE failed earlier that same day. So having two failures, a year apart is bad. Having two failures in the same day is probably the only thing worse. Long March is pretty reliable. The 3B variant, is a fairly reliable launch vehicle. So it's surprising to see that one fail. And to have them both fail in the same day is unfortunate. And we hope that both of them get back to the pad quickly. I don't think there's any slowing the Long March down. So it's not like that failure is going to cause them to stop, because they've had like 6 launches of that rocket in the first couple weeks of the new year. Some interesting stuff about the rockets they have been launching. The Series 1S Y7 launched from a converted C platform called the Defu 15001 off the coast of Shandong. This is cool to see. We saw a rocket launch off of the Yellow Sea last year. So the fact that they have 2 sea launch platforms that they can use for their rockets is very impressive, seeing as how the U.S. has none. We actually have 2 failed sea launch platforms. So like Sea Launch, which was a failed company about a decade ago, and Seagate, which has yet to launch the Via space rocket, are going to be competing with these Chinese capabilities. Galactic Energy did announce a successful launch with 4 satellites for the Tianqi constellation, which successfully inserted into a high 850-kilometer, 45-degree inclination orbit. This is one of the more mature Internet of Things constellations for China and is operated by commercial startup Guodian Gaoke. A Long March 2C rocket launched from the Jiquan Satellite Launch Center in northwest China. The payload was an Algerian remote sensing satellite, 3A, known as ALSAT 3A. So another interesting trend in the Middle East and African space agents increase in space activity. And the first launch out of the year was China, the Long March 6A, carrying the Yaogan 5001 remote sensing spacecraft into a retrograde Earth orbit, which is another rare orbit. We're seeing a lot of cool rare orbits like Dusk Dawn, Sun Sync, and high polar like Molniya or Tundra orbits. Now a retrograde Earth orbit. So fun to see.
Yeah, there's some fun orbits that have been achieved and unique launches that are happening, sort of in line with what we discussed earlier about China's focus on the non-typical, non-polar, non-sun synchronous low Earth orbit altitudes. They're focusing a little bit more on the MEO and GEO stuff. But I agree with you that any sort of Long March failure is going to be a small setback for the Chinese launch and space program. But I do think that the back-to-back PSLV failures, specifically because the rocket itself was grounded for 6 months or 8 months, however long it's been, but it was basically grounded since the C61 failure in May, and coming back all loaded up and losing the C62 in the same way is indicative of a systematic or much bigger problem that needs to be solved. So hoping that PSLV is able to get back on the horse and get back in the saddle quickly. But if they had an 8-month delay after the first failure, I'd imagine that delay and that grounding becomes a little bit longer and a little bit more severe after the second repeated failure of the same or a similar type.
Yeah, it's tough because they're fairly early in their launch vehicle development cycle. They have some great capabilities, but a lot of it's propped up by Russian technology that's exchanged with them in order to build that technology. But the PSLVs had like 65 launches at this point, so they should have plenty of data to be, both improving the reliability of whatever existing technology they have, but also developing new technologies, some more sovereign Indian capability for launch vehicles. And we're starting to see that in the private space. So India is getting better about funding their private efforts to build rockets. This week, TDK Ventures backed Ethereal Exploration Guild and their Series A to pioneer a fully reusable medium lift launcher. So that would be the first reusable vehicle for India, which is a huge step forward. And it's privately developed, so you can do that in parallel with ISRO. It's also a medium lift launcher, which is pretty ambitious for a private tech company. Most of them start with small and then go up to medium and then large. So it's really good to see that. I think there's also a medium lift launcher coming out of Canada, which is also surprising because Canada doesn't really have any launch vehicles that they can use for orbit. But the Canada Rocket Company has entered the Launch the North sweepstakes and raised $6.2 million in a seed round to develop a Canadian medium lift vehicle. So best of luck to both countries. Those would be amazing capabilities for them to stand up and gain sovereign launch capability. Additionally, Japanese launch vehicle startup Interstellar Technologies has raised nearly $130 million to continue development of its Zero small launch vehicle, which, again, great to see private companies building out an extended arsenal of launch vehicles. We were talking about the H-3 rocket previously. That was built by Mitsubishi Heavy Industries. So a new player in the field building out a small launch vehicle will be a good addition to the fleet of vehicles that Japan has access to.
On to the business moves for this week. Very busy. Lot going on, lot to talk about, and a lot happening. We'll start off with some of the ISR and space intelligence news that we alluded to earlier in the show. But Parsons buys Altamira for $375 million to expand their space and intelligence portfolio. The acquisition brings missile warning and space data analytics capabilities in-house for Parsons. And again, this is a continued trend of defense and national security capabilities getting massive amounts of investment, massive amounts of private capital, and consolidating substantially. So ISR continues to grow and trend. It's an ongoing and continuing hot market, and there's really no reason to expect this trend to stop anytime soon. Additionally, SkyFi has raised over $12.5 million to scale a satellite data marketplace. Funding backs expansion of the, quote, virtual constellation that aggregates imagery from commercial operators. We've seen a lot of different startups and a lot of different companies trying to solve this problem. One of the biggest challenges is that any sort of marketplace winds up being more akin to a standards war than like a product or a capabilities war. So most marketplaces wind up being effectively winner takes all or winner takes most. Once you sort of establish that this, that, or the other is the marketplace, there's really not a whole lot of room for anybody else to enter the space after that. So $12 million raise doesn't necessarily make SkyFi royalty. That amount of capital on its own won't necessarily king or queen make them out of the gate. But this raise comes off the back of some of their integrations with ISI and Vantor, who are major whales in the industry to win. ISI has the biggest SAR network by, I believe, an order of magnitude, but it's big. And Vantar is another major player in Earth observation data. So those partnerships have pretty clearly sort of de-risked what is traditionally a really risky investment for investors, marketplaces, and these sort of standards wars that are winner take all. And so off the back of those partnerships, SkyFi has raised their 12.5 million, 12.7 million, and they're effectively off to the races now. Additionally, friend of the show, HydroSat, as we mentioned at the start of the show, at the top of the show, HydroSat is a thermal image company, a thermal image startup focused on water resource management. They closed a $60 million Series B of funding from equity investors and sovereign wealth funds. With this influx of capital, what they're planning to do is effectively put up additional birds and expand their global footprint. Whether or not they're planning on internalizing those birds, they bought the first satellite that they operated from, I believe it was it Muon or Loft?
I think it was Loft and then Muon.
Okay, so they but the point being that they acquired their first satellites from other established satellite manufacturers. So it's unclear whether the 60 million is intended for them to in-house that capability and start building their custom satellites in-house, or whether they're still going to be buying that out and contracting that out just in order to increase the capacity, and their proprietary moat is going to remain on the sensor, the payload, and the analytics and data insights derived therefrom. But
do you think the sovereign wealth funds could indicate that it's like Saudi money that's buying their sensor capabilities? Because we're seeing an increase in that business, and there's a lot of value in water resource management for those regions.
Absolutely. I mean, it's absolutely possible. That's one of the biggest trends that we've seen over the past couple of years has been massive influxes in capital and relationship and partnership with some of our Middle East collaborators, Middle Eastern collaborators. And so Saudi, UAE, those are nations that have been effectively trying to buy capabilities in space for a while. I believe we worked on a couple of projects previously that were that could have been described in that way as well. But this is not something that would surprise me if some of these sovereign funds themselves were Saudi or UAE money looking to try and buy some of the space capability and get into the industry with a stronger foothold. Cesium Astro has secured $200 million in government financing. The Export-Import Bank of the U.S., EXIM, and J.P. Morgan jointly provided the batch of financing.
This one's really interesting because Cesium Astro is not, but they haven't been a primary player in the proliferated networks or PWSA or anything like that, but they have a really impressive technology stack. It's a high power phased array antenna that has one of the best like throughputs and signal noise ratios on the market. And it looks like they have plans to build their own constellation that's kind of built on the back of this. So, 200 million could go a long way in getting them to build out their own proliferated network. Although I'd be interested to see, if they start providing it for other programs, like particularly the PWSA things. I think this is like a made in Texas, American homegrown like comms capability. So I would really expect Cesium to start showing up in some of these PWSA tranches or get some sort of large MDA Shield award. I don't think I would expect to see them propose their own like self-owned proliferated network unless they're proposing some very unique capability that differentiates them from Starlink.
Yeah, so this funding comes as part of the Make More in America initiative out of EXIM. And Cesium Astro is allocating that money to fuel their vertically integrated manufacturing operations and enable them to deliver their future space systems for connect, detect, and defend across government, national security, and commercial missions. So very much in line with the sovereign security capabilities that we've seen play out both domestically and internationally. CENTCOM was awarded a SpaceWorks contract for resilient ground infrastructure. Typically, ground infrastructure has remained an area of the communications layer that has been commercially underfunded. So it's good to see SpaceWorks, and it's good to see additional sources of capital helping to bridge and assuage that infrastructure gap. The biggest announcement that we have, just in sheer terms of dollar value, is that Hadrian said it had raised an undisclosed amount of capital at a $1.6 billion valuation, led by T. Rowe Price, with some participation from Altimeter Capital, D1 Capital Partners, Stepstone Group, Founders Fund, Lux Capital, A16Z, Construct Capital, and 1789 Capital.
So just all of them.
all of the big defense tech players, all of the big names are here playing around with Hadrian. They are very well positioned for some of the defense and some of the national security contracts that we're expecting to see come out, be it either from MDA or the Proliferated War Network. But they are well set up to execute on some major domestic defense manufacturing contracts, though we'll need to keep an eye and see how they're able to actually execute on the AI-based factory, the AI-first factory that they're quoting as their primary product at.
Yeah, I mean, they had that partnership with Lockheed we announced a couple months ago, so they've got some big investors and big customers, and now it's just going to see how they execute.
Additionally, GomSpace Luxembourg secured a €3 million contract with a North American space company to design 2 small satellites for a lunar exploration mission. This is on the back of an additional award that they got last month from AppleLink out of the Bay Area here in California, I believe out of Palo Alto. So GomSpace Luxembourg, primarily lunar focused, is making some progress and winning some meaningful contracts there. So congratulations to them. Additionally, Ariane Group has established the Southern America subsidiary in the U.S. with the intent of increasing and standing up their American manufacturing presence. It is objectively a pretty risky move. The upside of this is clearly that they're looking to sort of mirror Avio's success, having won a couple of major contracts from Lockheed Martin, having been onshored and brought to America primarily off the bat of their solid rocket missile manufacturing capabilities. Ariane Group is pretty clearly looking to try and replicate that success for their M51 missiles, and standing up the Southern America subsidiary would give them manufacturing capability on American soil and the ability to win and contribute to some of those same government contracts. But the stated goal of being able to onshore to America space manufacturing equipment for commercial and potentially government use, that is a much riskier ploy. So I personally would imagine this as, hey, we see what Avio is doing. We're going to do the same thing. Effectively, we're going to onshore our solid rocket, our missile manufacturing capabilities so that we can compete and bid and try and win some of those same contracts. And everything for the space equipment manufacturing is just sort of additional fun gravy, if you will. Finally, iSpace has initiated and stood up a new subsidiary out in Saudi Arabia, following with the same pattern that we've been talking previously. They are advancing sort of their lunar exploration partnerships, and this is the 4th global entity with whom they've done this. So they've done this with Japan, Luxembourg, and the U.S. previously, and much in the same way that neither of us would be surprised if some of the wealth funds that have contributed to Hydrosat are based out of Saudi Arabia. We're seeing similar investment and similar prioritization of Saudi Arabian capital out of other commercial companies as well. Yeah,
there's definitely an increase in space capabilities in the Middle East. I think it's going to be one of the most emerging regions in this probably next year, not this year. they still got a ways to go. United Arab Emirates and Saudi Arabia are pretty aggressively pursuing this. Egypt has been chosen to be the center of this Middle East African space agency that's kind of a consortium amongst these states. And they're building out their own launch pads down in northern Africa. So lots of stuff to watch here. There's been plenty of satellites launched across a lot of African and Middle Eastern nations. And of course, Israel has their own space agency. So it's not foreign to the region, but it's definitely an interesting area to watch. So for the tech advances this week, these are news that don't really fall into the major trends we're seeing or any particular business move, but are still interesting to talk about. We have PsiQuantum announced that the company is collaborating with Airbus, Europe's largest aeronautics and space company, to advance applications in aerospace for fault-tolerant quantum computers. So this, when we bring up quantum, we usually talk about it in the context of in-space quantum applications, but in this case, it seems more that PsiQuantum is going to use their quantum computers to do solve complex problems for Airbus. So, quantum algorithms for fluid mechanics and other compute-intensive problems. This is great to see an application on quantum computers. These are some of the best use cases for it. So just seeing another big prime kind of get on board with using this technology more often is great for the quantum industry. And hopefully it leads to some improvements in the computers that can then be brought up to orbit, because we're starting to see more talk about quantum computers on spacecraft, particularly with IonQ in the past few months with their establishment and acquisition of a bunch of companies to kind of develop that technology. So, another indicator that there's some growth and interest in quantum computing on orbit. And, I hope this collaboration goes great. On that same trend, we have a quantum company that's talking about imagers. Diffraction is coming out of stealth this week with a $4.2 million pre-seed round. And they're positioning this funding to move towards deployment for SDA use cases. So what their product is a camera that's based on quantum technology that allows it to see faster and compute faster. And it's just a quantum leap, for lack of a better term, in imaging technology. So, a lot of the news that we hear recently about imagery is moving a lot of the processing to the edge. So that means deploying AI to satellites to take images and pull insight out of it. So that way we don't have to send full images down to the ground and process it there, because the bottleneck continues to be downlink throughput. So the more that we can do on orbit, the better. This company is proposing that their satellites are able to see more and process better on orbit and get those insights quicker. That's great. One of the obvious use cases for that is space domain awareness, so that you don't have that delay between sending it to the ground, receiving insights back, and then doing some sort of action upon it. I could see this being another huge leap in capability for some of these space defense applications. And pre-seed, they're pretty early. That's a pretty big raise, $4.2 million for a pre-seed. So hopefully it goes a long way to deploying this technology. And I'm looking forward to hearing about them, launching the space and testing out this tech.
Yeah. So the 4.2 million raise includes a D2P2 from DARPA of roughly 1.5 million. So that's more akin to like a 2.5, $2.7 million raised in equity, which falls a little bit more closely in line with a pre-seed raise. But the capabilities of their Galileo 1, the quantum camera, are reportedly really impressive. So they're able to bypass the diffraction limit, the sort of the physical boundary of the maximum resolution that your camera lens can get based on its aperture size. And they're doing that with the combination of some of the advanced photon counting sensors that they have. So some of the advanced hardware and sensors that's going into their actual payload, but also the quantum computing and AI-backed interpolation on the back end is able to help them deliver up to reportedly an order of magnitude higher resolution at several orders of magnitude. They're reporting 3 orders of magnitude lower processing times. So this constitutes a a meaningful step change in how data is currently processed, transferred, and handled throughout the communication layer and effectively space's telecommunication pipes, if you will. This represents just orders of magnitude improvement to the plumbing.
Yeah, I think it couldn't come at a better time as we're starting to see more satellites go into orbit, like increasing the speed at which we can track them. And from the distances that we can track them, it's going to be huge. CARB-SAR IOD mission is designed to demonstrate the performance of Oxford Space Systems wrapped rib antenna as part of Surrey Satellite Technologies' latest synthetic aperture radar demonstration mission on their proven carbonite tech platform. So this is a unique deployable system for synthetic aperture radar. It's in a pretty small form factor. I believe it's 3U or 6U CubeSat, but they're able to deploy to a much larger footprint to generate synthetic aperture radar. This will be interesting to watch because it's a pretty small form factor compared to a lot of the other SAR satellites that typically are very big. But we're starting to see some other approaches to SAR satellites, like we talked about Array Labs last week. They have a pretty unique take on it compared to like traditional ISI, Capella, Umbra platforms or like NISAR or RadarSat. So this small form factor is an interesting one to watch. Obviously, you need a large footprint in order to catch the radar as it's being bounced back. So if they're able to do that in some deployable form factor, that could be very interesting, both just for being able to deploy more in a sort of formation flying situation rather than large, monolithic satellites like NISAR or RadarSat, or potentially even having them as secondary payloads. A lot of the times when synthetic aperture radar companies are going to traditional satellite manufacturers, those manufacturers have to turn them away because the satellites aren't designed for that type of payload. But if they can get this sort of deployable technology down, it might open the doors for a lot more collaboration between traditional satellites. Voyager Technologies has secured a patent for in-orbit manufacturing of crystals for optical communications. These are microgravity-enabled manufacturing methods to produce larger, purer crystals used in high-performance optical communications, critical for optical comms as the backbone for data centers and the AI-driven economy. This is interesting news right after the back of Space Forge claiming, victory in their on-orbit test of their crystalline forge a couple of weeks ago, at the beginning of the year. So two companies, claiming progress in the ability to manufacture crystals on orbit. This is for more at-scale manufacturing, which we had the privilege of talking to Andrew Carlick a couple of weeks ago from Space Phoenix about. This industry has huge potential, but for a long time it's been on the kind of scale of demonstrations. A decade ago, there was, fiber optics being manufactured by Made in Space in the ISS. So we know this is possible. So for some of these technologies that are being announced more recently, it's less so about proving that we can do it and more so proving that we can do it at scale. And the potential for this technology is huge. There's been research that shows, a kilogram of some of these crystals could be worth hundreds of thousands of dollars. And they can be used for relaying data on the ground if we return that material, or more exciting to me is that we could use it on orbit as we build out orbital data centers where this could be valuable, or we increasingly rely on optical communication between satellites, which could also benefit from this technology. KSF Space has commercialized additive manufactured PA-11 CubeSat structures to expand the company's lineup and lower costs and broaden access for small sat missions. So this is great to see. This is additive manufacturing we've talked about a few times. Last week it was with Momentus's additive manufactured fuel tank. This has been technology that's been, researched to death for years now. Relativity space has kind of been the big player in this field. But I'd love to see some progress being made on the CubeSat side of things. Additive manufacturing makes a lot of sense here. If it can scale to, allow for rapid production of CubeSats, that enables a lot of research capability, which should hopefully get companies to space quicker. Lastly, another update from the Twilight mission, which was the Falcon 9 launch to dusk dawn sun-sync orbit last week. We've been talking about it since last week because there were quite a few interesting missions. We talked about it earlier with Kepler and their 10 satellites, but on board were also two Axiom space orbital data center nodes. So this is ODC nodes 1 and 2 and are a critical step in the progress to deploy a multitude of free flyer ODC nodes in low Earth orbit. This is interesting for a number of reasons. Orbital data centers has been huge in the news for the past couple of months. And Axiom wasn't even really one of the main names being thrown around to like get on this trend. It's been like SpaceX, it's been Planet with Google, it's been Aetherflux with their or Galactic Mind. The Star Cloud has been another big one. But for Axiom to just kind of like jump the line and say, "Oh, we're already there," is kind of cool. We talked about Lone Star doing it with some lunar orbital data centers as well as past week. So there's a couple players here, but Axiom I find particularly interesting. We keep bringing them up because Axiom in particular is for orbital habitats. I personally think orbital habitats actually make a lot of sense for orbital data centers. And Axiom is run by Cam Ghaffarian, who's the former ISS director and owns also Quantum Space and Intuitive Machines, the lunar lander company, and X Energy, the nuclear company. So he's got his hand on a multitude of companies that together form space infrastructure critical for us getting interplanetary. So I see this as a huge just step forward for Axiom. This hopefully is a new revenue stream. We talked last month about 4IG investing $100 million into Axiom with the express purpose of doing orbital data centers. So it's kind of crazy to see potentially their investment paying off within a month. And it makes a lot more sense why they're willing to throw so much money in so quickly if they knew about these data centers coming online this soon. So really excited to see what they do with these data centers. Excited to see if this scales out and becomes part of their core business offering. Well, that's a wrap for this week's recap of the space industry. We hope you enjoyed the episode, and a special thanks to Trevor Smith, CEO of Atomic-6, for joining us on this episode and telling us all about space armor and how it will help out Portal Space Systems on their upcoming Starburst 1 mission. As always, please drop us a comment, check out our socials, and follow us on Spotify, Apple Podcasts, YouTube, or wherever you're receiving this signal. Until next time, this is Harrison Lambert and Paul Mayer signing off for now.